meeting and the next meeting. But I wanted to give everyone just a heads up that we are always looking for new speakers. Up here in the top right-hand side, if you click here, it'll take you to a easy to fill out Google form. And and we encourage anyone and everyone to please go and give us a talk. We're interested in 15-minute talks, hour-long talks, whatever you can afford to do. And we love having first-time speakers because this is an open community and we're here to support each other and help each other out. So we're often encouraging to first-time speakers. So there's a couple other announcements. DEFCON 402 now has a bank account, a 501c3 bank account. Yes. So we can accept support or sponsored meetings. If you or your company would like to sponsor a meeting, that'd be awesome. And if you have any questions about that, you can talk to Brian, raise your hand, Jason, or me. And there's a couple other board members who couldn't make it tonight as well. But talk to any of us and get that going. We also
How much would I have to donate to you to wear a onesie to the next meeting?
It's negotiable. You can talk to me on that one.
How much would I have to pay to get you a onesie?
Everyone, that was John, our third worst speaker from the other month. So. Thank you, John. Let's see. We have a few other announcements. Colonel Con in 2020 is still happening at the end of March.
It's canceled.
What's that?
It's canceled.
Yeah. Well, we'll send out the cancellation email like a month ahead of time. It's happening at the end of March. If you're interested in volunteering, please let anyone on the Colonel Con OC, please raise your hand. Please let anyone raising their hand know. We can go ahead and get you added, or any other Colonel Con members, we can get you added to the Slack. And we're always looking for volunteers. We have a lot of work to do to meet up with our 2019 standards. So let's see. Did I have other announcements? Oh yeah. Last week we had a lot of people talking about jobs, and I wanted to just open up the floor. Does anyone have a job they'd like to announce for their company?
Hey guys, so I wanted to sit down. So I work at TSG, and right now we're hiring for our security operations department. So if you have security operations experience in an enterprise where you can do security monitoring or security automation, or working in any one of the variety of tools, do definitely let me know. I'll be over here. Yeah.
CSG is unlimited vacation, I'm just saying.
Thanks, boss.
Anyone else? Yep. Okay. Anyone else have? Is anyone else hiring for jobs? Okay.
Yeah.
Hey, so I got my challenge accepted at DEFCON. It's a network diagramming challenge. I am looking for one organizer. So if you're interested, I think they're going to provide the ticket. So there's that perk, and it's fun. So come find me. But yes, I'm excited. I got a challenge accepted.
Okay. Does anybody else have any other announcements before we get started? All right, it's my pleasure to introduce Jacob Moorbutter. He is a first-time speaker here at DEFCON 402, so please give it up. Give him a round of applause.
One second, let me get back to where I was. So yeah, thank you, Gus Goodman. I like this meme. I was laughing on the ground, going, heck yeah, that sounds about right. But as Adam said, my name is Jake Mulder. You can see me as Keyboard on the chat, and I'm going to be presenting over how to fuck up the public key infrastructure in every way possible. So before we get started there, and thank you very much. My background is mainly programming, C, C++, assembly, So that's where I started, 2012, when I was about 12. So I got into security many, many years later. And that brings me to some philosophical ideologies. Mainly, I see three big phases in software. All software systems go through a design and implementation phase. So you gotta design it, you gotta know how the data is gonna be organized, you gotta implement that. Then comes a maintenance cycle, and that lasts for X amount of time. And finally we get to obsolescence. That's like, hey, everything that's born dies, everything that starts ends. Hopefully. And it does come back around. I will get back around. I know this is a long way around. But let's say design and implementation. For this, I'd say it is the act of putting things in order. By its very nature, designing software, implementing software, it's anti-entropic. It's ordering. So it would be safe to say when something is freshly implemented, brand new design package, it is at the most ordered state it will ever be in. Here you are, you're at the top of the hill, this is a shit hill, all you gotta go is go down. No way further up. That takes me to maintenance. As you know, a software system that stops evolving falls behind the times. If it can't meet today's demands, it doesn't really become relevant. It doesn't stay relevant. So of course you gotta fix bugs. That's one of the big things that has to happen. And in fixing bugs, you introduce new states. You might not desire those states, they might be states you can predict, but you introduce new states. And those states, of course, introduce new entropy. You also have to add new features. Hey, your competitors added X, we need to add X as well. I don't know, but from a designer's perspective, introducing new features onto a software is something I'm not able to predict. This introduces states that can't be accounted for, states no one here could have predicted when they were designing or implementing a piece of software. This means that by its very nature, the maintenance cycle of software is entropic. It is the act of taking an ordered state and gradually turning it into an unordered state. It's not intentional, it happens. It's not linear either. Think about this. You introduce a new state. That introduces new bugs. New bugs mean you have to add new states. Add more features, new bugs, new states. Eventually, you just get to a point where you can't really keep maintaining it. It's too entropic. That is where obsolescence comes into play. It becomes the act of maintaining something that can't be maintained. You will add this new feature, everything fixes. You do this, everything fixes. That's where you start design and implementation again. And that'll all come back around later in the talk. But for now, I'm going to switch gears. I'm going to move over to the public key infrastructure. And I'm going to address kind of the topics behind it. You got confidentiality. Who here thinks they're gonna break RSA 2048 tomorrow? Probably not me. How about RSA 4096? Oh, you think so? How are you gonna do it? The government caught them?
Oh no, I thought you meant am I going to implement it tomorrow? I said,
No,
yeah.
break it.
Oh, no, never mind.
No? Same with the AES, same with that. Confidentiality is fine as long as you have integrity. And what we're going to find in the public key infrastructure is that integrity thing is what fucks everything up. And then that integrity thing even screws with availability. When the original designers created public key cryptography, they made it so that we don't have to rely on a third-party system. We could go ahead and say, hey, look, you have a data store with certificates inside of it, and just go get this. We can trust math, it's fair. But we can see that this authenticity, this integrity thing, it was kind of bolted on. The implementer said, hey, that whole authenticity thing, yeah, we just threw that in at the end. And much Moxie Ball specs dev contact, that's amazing. This is where I got this quote. It ends up being bolted on. Authenticity, integrity, that's all it does. Is it's like, oh, yeah, certificates and certificate authorities, that should take care of it. It ends up biting us in the ass. And it starts with the certificate revocation list. So, certificates need to be revoked. Me as a bad guy, I might go up, I would say, hey, let me purchase this certificate. I can use it for a while and then it gets revoked. Well, here's the problem. Certificates assume one of two states. That they are either valid or they're expired. Revoked is something that you had to check through a third party. That's because that's bolted on too. What we did was we said, hey, let's just organize it by serial number. Let's throw it up in a list. And whenever you get a new certificate, go up to that certificate revocation list and check if it exists. Well, okay, that requires an always online trusted third party. And if it's not online, say because I DDoS the crap out of it, well, now you go up and you say, hey, is there, oh, you don't have a certificate revocation list. You must be fine. Okay, I trust that certificate implicitly. Where does that happen? Well, RFCs to the rescue. When there are no revoked certificates, the revoked certificate list must be absent. You go up, there's no certificate revocation list, it's absent, okay. Otherwise, revoked certificate lists are organized by their serial numbers. Notice this organized by their serial numbers, it doesn't say ascending order, descending order. It doesn't say what order it has to be in. Coming out of that. Certificates revoked by the CA are uniquely identified by their certificate serial number. Okay, well, I kind of assume that. The date on which a revocation occurred is specified. The time for the revocation date must be expressed as described in another section. And I went to that section, it's just as ambiguous. Additional information may be supplied in the CRL extension. CRL entry extensions are discussed in 5.3. Again, I read over 5.3. It doesn't help very much if you're trying to design an interface. It says what's required, it doesn't say how that post request should work. So, thanks, RFCs. You tell us exactly what we need to know by telling us nothing we need to know. And it's kind of the same with this. Like, this is the timestamp thing that we were talking about. This field indicates the issuer date of this CRL. This update may be encoded in UTC time or generalized time. CRL issuers conforming to this profile must encode this update as UTC time for days through the year 2049. Well, I don't know, but the software package isn't going to be alive until 2049 that we're implementing today, so why do we even have to specify that? It just seems like unused information. Who's going to be using Oprah in the year 2050? How about, oh yeah, you might agree. It just becomes this ambiguous, what the hell? Give us the information we need to know. Give us an interface design. Give us an idea. This is how we do it. This is how the interface should work. This is how the push request should work. Don't try to be ambiguous. Just start out and say, here's what we need. Programmers are happy to fill in the blanks. I mean, I've read plenty of documents and I've been like, okay, I need to do this and this and this, and I just like jump through the hoops and say, I don't know what's going on here. Oh well, let's just fill in the blanks. If the spec isn't written well, no one will be working on the same assumptions. Think about it. There was just one example. How do we order the serial numbers? Is it ascending, descending? Does it really matter? Specifications need to be written so that there are no underlying assumptions. I should have to assume nothing about what request is going on. Communication or lack thereof, fiction. Think about it. You got somebody designing a certificate verification list for some really abstract certificate authority that no one's ever heard of, and then you have someone saying, "Oh, it works on Kubota. It must work everywhere." Does it? So we have this certificate verification list with a weird interface. Just doesn't work right. Communication is a problem in big overarching systems. So somehow the public key infrastructure works into 2011 under assumptions that people just guessed at. What changed though? Well, I love it's silent because BlackBerries are definitely better off after we see the push update with spyware. I'm definitely happy to know that someone was spying on me when I had a BlackBerry, which I never did. Part of the problem is this. We have several hundred certificate authorities. Can't just steal. That guy right there signed 270 individual certificate authorities. Here's the thing. This guy's a root. This guy's what you see in your browser. You don't see every other certificate authority. You see the square boxes. The round boxes means that they are intermediates. You don't see them. So, do we know this guy's implementing a certificate verification list properly? Do we know that some abstract browser is accessing that certificate verification list properly? I don't know. Probably not. But we don't see it. We just see the main, here's the roots. And that for me is kind of a problem. And then we get back to like Stuxnet, Flame, and all of those fun little malware samples. Yeah, it was nice to know that Stuxnet was a valid Militech device driver for 7 freaking months. But really, who cares? I just took down Iran's nuclear program, right? It's not like we could actively man in the middle of SSL for 2.5 freaking years. Thank you, Flame. They had valid certificates too. And all of this is because, I mean, look at the interfaces. Look at how it's designed. You can't audit it. You can't look at it. You can't see it. The problem here is, everything. Then we have things like actual certificate authorities that get compromised. And in 2011, Komodo, one of the biggest certificate authorities that I'm aware of, did get compromised. And the CEO's famous claim was it was a nation-state hacker. Yeah, I doubt that. And here's the proof. You can read it for the lols. Komodo hacker? Yeah. This is the guy that said, I have one hacker with the power of 1,000 hackers, and then he was talking about like not knowing facts. Oh yeah, I had to learn how to use APIs. Okay, good to know. You're one hacker with power of 1,000 hackers that doesn't understand an API. Okay. But he compromised one other. He compromised dc402. And it's probably because they had crappy passwords. You can find the passwords in the paste bin that Komodo hacker posted. They're not that hard. Anyone here could probably do for us and invest in an hour with pretty much anything you want. He did get dc402. He compromised it July 10th, 2011. They were removed as a trusted CA in September. And they went bankrupt about 18 days later. But they issued 531 certificates. That's 531 items that you trusted implicitly that were published by an unknown malicious entity that ended up being a 21-year-old hacker in Iran seeking revenge against the US. Yeah, that was great. Just think about that. One organization gets compromised, and now you trust 531 entities, right? Mozilla or Google. Get certificates for all of those. All the big names.
But would they be using that certificate authority, or don't they have their own?
He compromised the certificate authority, and then he himself got certificates for Google Play updates and Microsoft updates, so he could push updates out onto, your devices at any time. You didn't need permission. You could just do it.
I feel like there's a whole second half of that missing. Like the part where he's schooling you into actually going to his URL.
Yeah, he'd have to do that unless he could get control of the domain, and then he could do it, but he'd have to pull some social engineering or do something like that to actually make it work. But the fact is, this guy has the ability to do it with an SSL, and you look up in the corner of your browser, you'd see the little green padlock, and you'd be like, oh, it's fine, it's got the green padlock. I mean, yeah, that's kind of stuff with the updates.
He would have to take over a DNS server and...
Yeah, he would have had to do more to make it a threat, but imagine if this script kiddie was a nation state that actually was going for it for real.
Like the US server.
Yeah. I mean, we've seen what they can do with one certificate in Stuxnet or one certificate in Flame. So, 531 of these, and really he didn't need to issue that many. Just the fact that they existed, kind of a problem. But dc402 no longer exists. They're kind of gone.
Who?
dc402, they are one of the certificate authorities that used to exist. This guy has still the books on them. And sorry if I'm going kind of fast, I just have a lot to cover. And when I say a lot, Luke Glory could attest to the fact that there were, 60 slides?
A lot of slides.
Yeah, so, but, how the fuck do we audit this thing? That's what it boils down to. You have several certificate authorities, all interacting separately. Each one has their own internal list of certificates that are issued. No one really sees externally at that point. It's kind of like, oh yeah, they have a certificate. We can trace back and say that it is trusted by this group, but we don't have a full list of what's trusted. So externally, you're kind of blind. You don't see anything. this represents a problem. I mean, when's the last time that you said, oh yeah, we should be blind and not see what we're trusting? Sounds like a pretty bad idea, right? Any system that can't be audited is probably bullcrap. It's probably not safe. It's probably not secure. But there was a solution that Google found, and it was to bolt on a new component that enabled auditing. And boy, that was an amazing bolt-on. So I'd like to thank you, Google, for introducing the maintenance patch that finally pushed the public key infrastructure into the final phase of this software lifecycle, obsolescence. And by that I mean DKI has been on life support since 2011. There's no update that's going to fix what they did. And thus, we have certificate transparency. And when we get into this, here's how it kind of works. You would go up, you would submit a certificate that you found to a certificate log. They would collect the certificates up into a multiple hash tree like this, and they would sign the top hash. They would then, there's that. They would sign the head of the tree. After that, they would issue a signed certificate timestamp to that certificate. So it was signed as of this time. And that was kind of like preconceived time intervals. So they could issue SCT for a new certificate and wait until the next log was published. Which it works out great, doesn't it? But here's the thing. Certificates and SCTs are served to the client. The SCT is served to the client for one reason. It's to locate the log. Does that seem like a very good idea? You have several of these things, and each one of them is accessible with the SCT, but they're all separately linked. It's a good way for me to give someone a really bad view of the log. It does have benefits. It has a number of benefits. As long as clients have a valid view of the log, the state of the certificate can be ensured. So you go up to the certificate log and says, yeah, this certificate's been revoked. It's a good backup, it's a good measure to say, yeah, this is kind of what's going on. The local hash tree ensures that the data within the tree itself can't be tampered with. It's immutable. And the added bonus is when a certificate log collects certificates and publishes them, they can't deny signing the root or signing the head of that tree. In other words, if some certificate logs start acting outside of the normal, outside of what was expected, we could then instantly identify that log. Auditing for this system now becomes a lot easier. We can just go over SCT to SCT and say, yes, this is the certificate, this one's valid, this one's valid. Wait a second. We don't know that certificate was issued to Google. Maybe we should report to Google and ask them about it. It becomes a little bit easier to audit this thing. And that's a big step forward. So woohoo, at that point, problem solved, right? I'm time to go home. Everyone has it working. Kind of, maybe not. But we can fuck with this. And I think a lot of people probably already see kind of where this is going. An attacker can go and buy a valid log or a valid certificate, and then they instantly go and they submit the log to a certificate log, which it gets published to. They in return get the signed certificate timestamp back. At this point, they have everything they need. The attacker can then say, hey, here victim, take this certificate and this SCT. They don't need to send the SCT that the website was going to send them. They just send the original SCT. In other words, they're going to get the wrong view of the local hash tree. They're going to get the wrong view of the log. They're not going to know what's going on. They're going to validate it. They're going to say, oh, yeah, it looks good. Even if a revocation was made in the very next local hash tree, for this view of the log, everything's still fine. Everything works. They connect. They say, yep, we're good. Problem solved, right? Yeah.
Is the SCT requested from the browser or from the decryptor to an authority?
You would
But
go.
you're saying that they are sending you an SCT. How does that?
So, the way this works is the certificate timestamps are signed by the certificate logs. So, when I go up and I submit a certificate to the log, I get an SCT in return. That SCT is always signed, so it's not repeatable. The next person that goes and says, no, this is revoked, and submits the revocation to the log, will get their own SCT. And that will be always sent from the domain back.
But isn't the client going to request it from the authority and see what the most recent one?
Yeah, it's going to try, but if you can control that, it's still signed.
Yeah, that's what I was getting at. So you're thinking you can take over these
Yeah, this was actually a documented attack.
Huh.
So yes, this actually has happened.
Okay, that's interesting.
So you can send that back and it validates. And you say, yeah, see my view of the log. Don't see anyone else's. And I can get you the link to that in the Slack channel later, just email me. And I'll send you that paper. But still, it's fragmented. That's the problem. Everything's ordered sequentially. You can't really fix that. I mean, what bolt-on component will allow you to say, no, that's wrong? And I couldn't think of a bolt-on component right off the top of my head.
Just run the results through sort.
You could try. I wouldn't know if that would work. Just because they're time sequentially ordered, and you're accessing them by the signed certificate timestamp. So if you have an invalid signed certificate timestamp, you're not going to look for them. You're going to go to that local hash tree. You're going to validate that it was signed. You're going to validate the certificate, and you're going to validate literally nothing else. So
then it could be fixed by when you go to do the validation, you see that you've been given a non-recent
but
timestamp,
yeah, but
and
here's
send
the
the client an actual recent timestamp.
here's the problem. All of these are certificates.
Yeah.
Some of these are valid. Not all of them are invalid. There's only one that's been added to this log that's invalid. So when you go to validate it, what's to say this certificate is invalid and this certificate is valid? Remember, this thing's immutable. You can't change it. It's been signed, it's added to the log. That's how they designed it, is to be immutable. It can't be modified. It can't be changed. So, going up and saying, hey, is this thing valid? Well, now you would have to go from log to log and say, okay, is this certificate anywhere along every log forward in time? It becomes kind of tedious.
Wouldn't the SCT be associated with the serial number of the certificate?
No, no, it's not. It's issued separately from the certificate itself.
So then what links the two other than here, this is for that?
That's the problem. They didn't think that through. That's the entire problem. Is exactly what you're hammering at.
Okay. Alright, you can go on.
So, I think I just passed benefits. So yeah, the victim sees that, they say, yep, it works, and then we're back to square one because we can get a certificate to it. And I will send a link on that. I'll make sure to get that up there because I want to back up my facts and make sure that everyone knows that, yeah, I'm not just BSing up here. I don't know of a way forward. If someone can think through a way forward, please ping me and tell me how much of an idiot I am, because I would love to learn something.
Well, if it's stored in the database, if you link the certificate ID to your SCT, then you can do a lookup and order it by most recent, and if they're providing you an older SCT, but no, here's the most modern.
Yeah, we could do that, but is someone going to figure out how to mess with that?
Right?
Yeah,
They pay
Google.
their engineer a lot of money.
Yes, yes. Okay, let me get back on track. I'm trying to think of what I was going to say next. But yeah, you do have valid points. But is it just another bolt-on component? Or are we just going further down the obsolescence rabbit hole? Yes, it's a modification. It's a bolt-on. It's gonna change states. It's gonna make more entropy. It's gonna go further down into the obsolescence field. Are we just trying to maintain a system that is going to fail eventually? Who's gonna find the next thing? I don't know what the next thing is gonna be. But yeah, I think maybe we're not back to square one because we can bolt something more onto it. And you may have valid points, but I'm not sure.
Has been running for how long, and they just keep bolting stuff onto it?
Yeah, they just keep bolting stuff onto it.
It works great. Sorry.
Yeah, you kind of destroyed my talk there. But I was gonna say there are some important design considerations that we could use to maybe design a better system that works efficiently, that avoids bolting on, maybe scrap it and start over. I mean, I know the problem with doing that. That's gonna be hard. It's gonna
Because
take
there's an
us.
option. If you go and scrap it, and say 30 other people aren't going to, and then how are you going to get the majority of clients to grab your solution?
Yes, that would be one of the big problems. It would have to be something where we made the interface work. There's not ideal solutions, and that's because authenticity was not what was considered first. Sorry guys, now I'm like off track by so far that I don't know where to go back to. There are takeaways from this system. Maybe some important design considerations for next generation public key infrastructure. I'm not gonna say that it's a good idea to like say, hey, you had to now switch over to the smooth system. Maybe transitioning into it would be a good approach. But I'm saying maybe it's a good idea to start designing a next generation system and having that talk. Certificates need to have the ability to kind of assume a replication state. Because, I mean, what if I DDoS all the certificate logs and now you just can't go up there?
Would a timeout result in an error?
Timeouts result in you saying, oh, there's no this. Okay. It goes up, it's gonna say, hey, can I have the certificate replication list? And it's gonna say, we're not here right now. And then it's gonna be like, oh, okay. That works. Or just assume it's safe. Even if we pop up something to the client that says, we can't validate the state of this certificate, but it is valid for now. They're gonna be like, what's this one about? And click good. I was gonna say certificates need to have the ability to automatically assume a replication state. There has to be a way that they can assume that state, and there has to be a way for us to do this so that everyone can agree on the same to the log. Public ledger certificate transparency may have solved the visibility, but we can do better. I I can think of several other data structures very similar to certificate transparency that we can use that offer the immutability, but use smart contracts instead and say, yes, this is revoked, and that's because we're referring to a document that stores the state. You don't have to go up and start sorting things and making it all work that way. And that would still keep that visibility aspect working. The design should construct an immutable account of actions that protect the actual state of the certificate. In other words, I should be able to go through the log and say, this is where it was issued, this is where it was revoked. I should have a nice timeline, kind of what certificate, kind of like what certificate transparency offers, but maybe a little more robust. Something that's going to work a little longer. It's going to work without you having to have the signed certificate timestamp. Something where, as long as you know where to find the certificate, you can always validate it without saying, okay, am I getting the wrong view? The current cryptographic functionality of the public key infrastructure should be maintained. But that doesn't mean it should be a bolt-on. Whatever decision we decide to make to say, okay, let's start designing the next generation and implementing this, all of the triangles in the integrity, confidentiality, availability, the CIA triangle, it should be considered thorough. It doesn't need to be a bolt-on solution. There shouldn't be a need to bolt on more components, more components, and more components, because that introduces new states. Those states introduce entropy. The entropy leads to obsolescence. And thank you for putting up with me, and I hope my talk was okay. I'm sorry about getting off track there. I wasn't anticipating that, but here's a Moto PDF. This is all the research I've done over the course of the semester into it. Please ping me on chat, on the Slack. Tell me what I did wrong, if I did anything. If you find facts that contradict what I was saying, please let me know. I don't want to be talking nonsense. But I'm fairly confident in what I was saying. And thank you. Any questions?
Yes. Alright. So I agree with you in a way that bolt-on isn't always the best solution, right? Like for instance, the reason we have IPv6, which none of you will really adopt, is because you couldn't really bolt on an extra 32 bits to our current 32-bit IPv6. Right? It wasn't possible. So they made it in IPv6, but there was nothing forcing us to use IPv6. We all had enough internal addresses and people, businesses dying, we could grab their IPs. It just worked out, right?
Yeah.
Then you have things like, I remember a few years ago where they deprecated SSL, we all had to use TLS, TLS1.2, TLS1.3, right? But it was our regulatory committees, like our PCI, et cetera, that said, hey, you have to use 1.2, you have to use 1.3, you can no longer use SSL. So as I was saying before, if we were to scrap this whole system, 30 other people are going to pop up with their own systems. We see it with cryptocurrency. We've got 150 million different cryptocurrencies.
Yeah, those very good.
Because nobody's going to enforce that upon us that we have to use that.
Yeah, and I see
the
you
reason
taking
this
this
has gotten as big as it is because we have big companies like Mozilla and Google behind it, and there's a public trust in this company. So in order for us to keep using it and be secure and have some form of conformity on the internet instead of having 30 different solutions, is to let them bolt stuff on and eventually deprecate something into a new version.
Yeah, and I agree with you. I'm not saying let's just stop trusting it flat out. I'm saying as a community, big companies need to be pushing on a next generation solution.
But we
I'm
need
not-
regulation to force us into using it, or else we'll just all go our own way.
Yeah, and I see what you're saying. I understand that. And I'm not saying it's an easy solution. I'm saying let's deprecate items, let's make things work. And I'm saying on a large scale, coming together. I'm not saying let's all come up with the next solution right here, right now, and implement it. Because you're right, it will result in fragmentation. I'm saying on a large scale, we need to come together and say, okay, what's failing? How can we fix it and work towards it as a community on one solution? And I mean, it's kind of, I get where you're coming from. I didn't consider it from that point of view, but I get where you're coming from. It does become tedious. But when are we going to hit the obsolescence zone? When do we go from we're maintaining a system to everything's growing up? I mean,
I don't know
To
how long
be fair,
this will last.
organizations like DCI don't come up with technologies. It's talks like this that point out the shortcomings in existing technologies, and groups that start to build the next generation, and then organizations that are reactive,
Well, I'm not
like
saying
DCI,
they build it,
adopt
but they regulate it. Like, you can't use this older deprecated technology, or else we won't certify you. You can't use it.
Sure, but there has to be the next one before they can deprecated. So the only way the next technology gets invented is when there's a groundswell of dissenting voices that say, hey, this current technology is not good enough. We need something better. And then you get researchers and organizations like NSA and others that start to build the next generation. And then once the next generation has proved itself and started to be adopted in a small group, then a reactive organization like PCI adopts and says, hey, we need to go use this. And companies like Google say, hey, we need to go to the next generation. And that's how it happens. I think that the beginning of that loop are groups like this saying, this technology is no longer good enough. We need to start looking at the next one. And then those resources start to, and I think you've done a really good job of pointing out some of those ways that PKI is showing its age. I think there's a lot of ways that it could be better. So thank you.
yeah, I wasn't expecting to be interrogated in the middle of the conference. Sorry about that.
It's a good thing. It makes you think.
Yeah, it does. And thank you for making me think outside the box. I was going like one-sided down it.
We all do.
So, but I'm not saying let's go out and implement it today. I'm saying let's start the conversation and get the community into it.
So to start that conversation, how big's the problem? Right, like you pointed out some very good things with Stuxnet. You pointed out a couple of other things. Like, does anybody have
Shadow Hammer happened about 6 months
But
ago.
what's the dollar impact? What's the impact to business, to national security, to countries? Like, what is the actual impact? I mean, we're talking about millions of certificates, and if somebody gets a hold of 100,000 of them, like, if that's
Billions.
1/100000th of a percent, like, do we really care? Like, before we can groundswell, what's the impact? Who cares? Like, I'm opening that up to everyone, right? Of like, how do you quantify this to say this actually is a problem? I'm not refuting that it is or it isn't. Just what's the data behind it?
It's obviously a large problem because our entire internet, as we know it, is ported over to HTTPS, and that requires certificates. So that means our entire internet, as we know it, is affected by this.
But is it? What's going wrong with the way the internet's working right now? That every once in a while a couple certificates get compromised and there's no trust on what's occurring over that then?
Yeah, and then those lead to instances of you not being able to trust any certificate of that manner. I mean, how many times has a certificate been compromised and gone unnoticed? And I guess you kind of have a point too. The monetary effect might be there, but let me ask you something. Do you have an Asus computer? No? So, did you hear about what happened with Asus computers? With Shadowhammer? Yeah, that happened because there was an invalid but valid certificate. Would you want to be one of those 651 individuals directly affected? Or what if they went larger and affected every ASUS computer? What if they just blanket targeted everyone? That's 6 months, 8 months. So,
yeah, because they did the same thing with Lenovo. They had a software package that came at install that basically forced you to use their certificates
yeah.
and trust it implicitly.
Yeah, so it would be research that I would have to conduct. And a lot of this was just on the theory ground that I was basing this talk. And I did go and I'll start doing some research into that stuff if you're interested, and I'll see if I can find a dollar amount. But I'm sure it's nothing small. So, forgive me for not having a better answer at this point.
That's part of learning, Jared. Don't worry about it.
Yeah. Any other questions?
Tell us about Jared.
Ask Michael about Care Bears. Ask Michael Bourne right here about Care Bears. He's right here.